If you are building a sorting system, an automated robot, or anything that need to see color, you know the ultimate enemy: inconsistent lighting. Your project works until a cloud passes or someone turns on a fluorescent lamp. That variability ruins your data and tanks your project's reliability. Today, we end that frustration. We are going beyond simple RGB sensing and installing a professional-grade visual system that doesn't care about ambient lighting. We are using the versatile ESP32 cam to stream video and OpenCV to implement the gold standard in color filtering, HSV masking. I'm going to show you the code and steps to build a color detector that is rock solid every time. Every great project needs a great gear. For our hardware, we are using the ESP32 cam. It's a dual-core 32-bit microcontroller that uniquely integrates Wi-Fi, Bluetooth and onboard over 2640 camera. It's the reason we can tackle image-driven IoT application on a budget. We first flashed it with a standard web server sketch. This code basically turns the ESP32 cam into a tiny Wi-Fi camera, streaming raw pixel data over your network. You get an IP address and that's our crucial stream endpoint. If you don't know how to upload program in ESP32 cam, you can check out my previous video. ESP32 gives us the raw stream, but to actually see that video and process it, we need a Python script on our computer. If you don't have Python, you can grab it from python.org. It's step 1. Once Python is installed, we need two critical libraries. Open your command prompt and first we install numpy, which handles all the essential array math. Type pip install numpy. Next, we install our computer vision core OpenCV. Type pip install opencv-python. This open source computer vision library is the world's standard for real-time computer vision, giving us the thousands of optimized algorithms used by everyone from startup to major robotic companies. The code idea is simple. We tell the code the specific range of HSV values we are looking for. We set a lower bound and an upper bound for the hue, saturation and value. Whatever pixel data falls inside the 3-dimensional range is what we desire to see. This is the HSV masking that gives a truly reliable vision system. First, we will open a basic Python script. We need to tell the code where to find the video stream. So we start by placing our ESP32 cam's IP address right here. For this test, the code is set to detect blue only. Save this file as .py and run it. And there you have it. Perfect blue color detection no matter what the light condition is. That's the power of HSV. Next, open our final advanced code. Just as before, replace the IP address. This code contains predefined HSV value for multiple colors, allowing you to detect red, blue, green, white all at once. You can even modify this code with the help of tools like Gemini to find HSV ranges for different colors you might need. Save it as final.py. Run the script and here you go. Now you can detect multiple colors simultaneously and use this foundational code in countless projects, from automated sorting to robot navigation. So what are you waiting for? You have the hardware, the code and the crucial HSV knowledge. Go and build something awesome.